Hello students, hope you are doing good. Um, I have I have a lot of students asking questions about implicit derivatives. So what I'm going to do is I'm going to talk about implicit differentiation. Maybe do a couple of questions on finding derivatives of those functions or rather relations, and then I'm going to go ahead and define the derivative of the natural log function also using implicit derivatives. So let's go ahead and start defining implicit what is an implicit function or a relation. So a relation usually what we have seen is usually you have seen functions written as f of x equals x squared plus x squared plus 7x minus 5. That's a quadratic function, right? Or we write it as y equals x squared plus 7x minus 5, or we write it as f of x equals x squared plus 7x minus 5, right? So it's y equals a function of x, right? That's a function written explicitly in terms of x. Now, if I give you a mix of functions, this is a nicely behaved function, continuous, and y is a function of x. But life is not that simple, or I would say that neat always, right? So a function could be a function or a relation or a graph could be in a complicated form, not as nice as this quadratic function. So suppose a function is given something different. Let's say x of y plus y squared equals, let's say, 5. Something like this is given. You can't factor out a y. I mean, you can factor out a y, but you cannot write this function explicitly in terms of x, right? You cannot, even if you factor out a y, you are still left with y in this factor, right? So this kind of functions, since this is a y square, actually this is not a function, this is the relation. But this kind of relation is written implicitly in terms of x and y. Now the question is, we still want to find the rate of change of this relation with respect to x. How is y changing with respect to x in this? If x is changing, is y changing as well? So basically we are still looking for y prime or dy by dx. So the derivative of y with respect to x. So how to find that? If you look at let's say this relation only, xy plus y square equals 5. X and y, these are two functions now. X, you can treat them separately, x as well as y. So if you want to find the derivative of this xy over here, what you want to do is you want to apply product rule, since this is the product of x and y. So applying product rule here in the first case, x and y, what's the derivative of x? It's 1 times y as it is plus x as it is. The derivative of y is nothing but y prime, which is dy by dx. So this is the derivative of xy. Y plus xy prime. Okay, let's find the derivative of y square. We are differentiating, we are finding the derivative with respect to x. So it's given y squared. It's not a function of x, it's y squared. So how to find the derivative of y squared with respect to x? You can use chain rule, like it's u squared, the derivative is 2u, and then you multiply by u prime, right? Similarly, if it's y squared, you take the derivative of y squared, which is 2y, right? Let's use the power rule. And then since we are using chain rule, this is not x, I have to multiply by y prime, and the derivative on the right side, 5, is 0. It could be 5x. I mean, right side could be anything. I just took it 5. So that's the equation in the derivative we have. Now we want to separate out, we are looking for y prime. So we want to separate out the terms which has y prime. So what I want to do is I'll keep these terms over here and move this y on the other side right here. Okay, so what I have is, if I keep this over here, I have xy prime. So let me write down, let me go on the other side. I have xy prime plus 2y y prime equals, the derivative of 5 was 0, equals negative x. I just want to make sure I did it correctly. So what I did is I moved, not x, y, I moved y on the other side, which becomes a negative y, and I kept xy prime plus 2y y prime on that side. So this is a negative y right here. Right? Now factor out a y prime. So y prime x plus 2y equals negative y. Y prime equals, divide both sides by x plus 2y, y over x plus 2y. So that's the derivative of y, that's the rate of change of y with respect to x of the given equation which was given on the last page, this implicit equation xy plus y square equals 5. Okay, so that's what I'm looking for here. Let's do another problem, maybe let's choose a complicated one. I have one written here on my paper. Let's choose this one. Suppose the function is like this, xy, okay, plus x squared minus 2x squared y squared equals 0. And I'm looking for the derivative of this one. Again, the derivative means I'm looking for y prime. I'm looking for the rate of change of y with respect to x. Okay. So what I want to do is, I can see here, right here, that's the easiest function I would say, or the beautiful one I would say is x squared. You know the derivative is 2x. So this one right here is 2x, the derivative, right? Now for xy, we have seen on the last example, we have to use product rule. So that's y. If I take the derivative of x, it's 1 times y, so it's y, plus x as it is, the derivative of y is y prime, plus 2x, and then comes, sorry, this was 2x squared, it didn't come here, then comes this thing here, this factor 2x squared y squared. Now again, this 2x squared y squared is a product of two factors, x squared and y squared. I can use three factors also, 2x squared y squared, but 2 is a constant, the number 2 is constant, so you can just keep it the constant outside and use the product rule for x squared and y squared. Using the product rule for x squared and y squared, the derivative of x squared is 2x, keeping y squared as it is, plus plus x squared. The derivative of y squared, it's again same thing, it's the derivative is 2y and power rule y prime, and then equals 0, right? I mean, it's the same function, it's just it's the same implicit equation, it's just more factors in this equation as compared to the last one. Okay, let's collect the terms with y prime. One is right here with y prime and one is right here with y prime, right? So let's collect them. I have xy prime, right, this one, minus this 2 when distributed becomes 4 x squared y prime equals, I'm taking everything else on the other side, so it's a negative y minus 2x, and then this becomes plus, so plus 4xy squared. Just look at it if it's correct. Yes, that looks correct. And then I factor out a y prime here. What I'm left with here is x minus 4x squared y, right, equals the same thing, minus y minus 2x plus 4xy squared. And then you divide both sides by this, x minus 4x squared y. So this cancels right here. I'm left with x minus 4x squared y, right? X minus 4x squared y. Okay, very good. So that's the derivative right here. That's the derivative of this function, of this relation, I would say. I'm not calling it a function, of this relation given implicitly, right? Now the next question, which you have seen before, actually finding the equation of tangent at a given point. If you look here, given x, let me say, let's go to the next slide. So what I'm saying is same function. The function is xy plus x squared minus 2x squared y squared equals 0. That's a curve, some kind of curve. It passes through the point 1 comma 1. All of you agree, because 1 plus 1 2 minus 2 makes it 0. So find the equation of the tangent at this point. That's the question. Okay, so the point is given, the slope is nothing but the derivative. So if you go back and plug in 1 comma 1 into this derivative right here, it's negative 1 minus 2, so negative 3 plus 4 is 1, so 1 in the numerator, and 1 minus 4, negative 3 in the denominator. So your m for at this point, the rate of change is it's negative 1/3. So use the equation y minus y1 equals m x minus x1. So which is same as y minus 1 equals negative 1/3 x minus 1. Right? So let's multiply by 3 over here. So it's 3y minus 3 equals minus of x plus 1, right? Or you can have it 3y plus x equals 4, right? If I did everything correctly, it's 3y plus x equals 4. That's my equation right here. Okay. Excuse me. So what I'm going to do is I'm going to show you this curve. I actually had drawn it before, and let me show you where that where I I'm sorry, not here, on the next slide. So what I'm going to do is I'm going to show you my curve here. That's the one. See here, that's the curve. If you look here, so if you look here, this is the okay, so that's the red one is the curve, actual curve given, xy plus x squared minus 2x squared y squared equals 0. 1 is the point where I'm finding the tangent, and 3y plus x equals 4 is the equation of the tangent that I just found out using my point slope form, right? So so this is the red one. As you can see, it's a relation, right? Xy plus x squared minus, that's the curve we were trying to find the derivative of. And then 3y plus x, I'm sorry, I just drawn 3y plus x equals 4 is the blue one, which is the equation of this tangent right here, this one. And then 1 is the point where this curve is passing through. Okay, let me give you a question here. As you can see, at x equals 1, the curve passes through another point, right? Over here, as you can see, there is a point. Can you find that point and also the equation of tangent at that point? I repeat the question, and that's the question of the next discussions. The question is, you can see it's a relation, right? At x equals 1, the curve passes through another point. So basically, you're looking for the y point here. Which is that y point? What's that y point? Once you have found that point, 1 comma whatever that point is, tell me or find the equation of the tangent at that point also. Okay, so that's the next question for discussions. So that's about implicit. If you want, I can do one more question, something like sine of xy equals let's say 5 of x. If you want to find the derivative of this function written implicitly, excuse me, so you can again you can use chain rule, and so the derivative of sine is cosine, right? All of us, you have seen this before. So just read this as u right now. So the derivative of sine u is cosine u, but then you have to multiply by u prime. So you have to multiply by xy prime equals, right side is simple, the derivative of 5x is 5. Okay. So you have cosine of xy. Again, we have seen this xy prime. This is the third example. Probably I should have chosen something else, but so if it's xy prime, you know the derivative is y plus x, y plus x y prime, right, equals 5, right? So distribute cosine xy. I need to isolate the term having the y prime. So if I distribute cosine xy, I have cosine xy times y, right, plus xy time prime xy primes times cosine xy equals 5, and then I'm going to move this to the other side, so that'll be 5 minus y cosine xy, and then divide by x cosine xy, right? So 5, so the answer will be, your y prime will be equal to finally 5 minus y cosine of xy divided by x cosine xy. Okay. So few examples on implicit. Hope you got an essence of it. I mean, how these equations work, how the rate of change in these equations work. The next thing is the derivatives of logarithms, the natural log. So far you have seen power rule, right? You know what that is. You have seen product rule, quotient rule, product, quotient. You have seen those, right? And then you have seen chain rule, right? Then you have seen the derivative of the exponential function. It's exponential. You have seen the derivatives of strict functions. So sine x is cosine x is sine x, and negative sine x, and then you have others that you can actually find using quotient rule, right? Or tangent is secant squared and so on. We haven't seen the derivative of natural log of x so far, right? So y equals natural log of x. I don't know how many of, I know you guys hate actually natural log function. It's not that bad, the natural log. That's actually the inverse of the exponential function. So they are the inverse of each other. So in other words, natural log of x and exponentials, they could be written interchangeably, and these are the two equations, those are equivalent since they are the inverses of each other. Okay. You might have seen this before in pre-cal or in college algebra. So we are looking for the rate of change of this function now, the natural log of x. To find the rate of change of this function, I don't know, I haven't done or seen anything before, but I do know the rate of change of the exponential function, right? The rate of change of the exponential is the exponential itself. So what I'll do is, instead of finding, these are the equivalent relations, equivalent equations. So instead of finding the rate of change or the derivative for this one, I'm gonna find the rate of change for this one. So let's find the derivative of this one. Now this function, this actually is written implicitly, right? It's not written as y equals a function of x. This function is written implicitly. It's a function, but it's written implicitly. So what I can do is, what's the derivative of exponential? It's the exponential, right? But since I'm dealing with y, I'm not dealing with x, I have to use chain rule and multiply by y prime. Okay, and I'm using implicit differentiation here. So e to the y prime equals, the right side is the derivative of x is 1. Very good. Isolate y prime. If I isolate y prime, I get 1 over e to the y. Go back to x. What was your e to the y? E to the y is x. So it's nothing but 1 over x. So the derivative of this equation right here is 1 over x. The derivative of the natural log function is 1 over x. So what I'm saying here is, if y equals natural log of x, then y prime, its derivative is reciprocal function, which is 1 over x. Okay. Now suppose I have y equals natural log of x squared. What will be the derivative of this? You don't have to do the e to the y thing all the times. You can use this now. Once you have the basic function, the parent function, you have the derivative. Now you can just use that derivative for the subsequent using chain rule. Okay, I have x squared here. I don't have x, that's fine. If I want to take the derivative, what natural log does is, the natural log, the derivative is the reciprocal. So it moves down to the denominator. But since this is x squared and not x, I was using this as u. So I have to multiply with the derivative of x squared. Okay, so it's 1 over x squared times the derivative of x squared is 2x. One of the x's cancelled, so I'm left with 2 over x. And those who know the properties, actually this 2 can come over here. It's still 2 over x. Let me do one more. For example, I have natural log of x squared plus x or 3x plus 4. What will be the derivative of this? This is my y. Let's say this is y. So I'm looking for y prime. What is the derivative of natural log? The reciprocal function. So what it does is it moves everything to the reciprocal, x squared plus 3x plus 4. But since this is not x, this is my u, right? I'm considering as x. So multiply by the derivative of this, which is x squared plus 3x plus 4 derivative. Okay, and what's the derivative of x squared is 2x. What's the derivative of 3x? It's 3 divided by x squared plus 3x plus 4, and that's your y prime. Okay, so let's do one more. What about natural log of sine x? What's the derivative of this function? Same thing, if I'm looking for y prime, I have to move sine to the denominator. That's my first thing. But since I'm using chain rule, I'm using this as my u. So multiply by the derivative of sine x, which is cosine x. So I have cosine x divided by sine x equals y prime, and that's nothing but cotangent x. So the natural log of sine x, the derivative is cotangent x. Okay, so this natural log of x can appear anywhere. It can appear in the product rules, it can appear in the quotient rules, but the basic thing is the derivative of the natural log of x is 1 over x. That's what you have to remember, that if y is natural log of x, then then its derivative, then the derivative is 1 over x. Let me do one question with product rule and one with the quotient rule. What about y equals x ln x? How would you find the derivative of this? Okay, this is a product of two functions right here. Function 1, function 2. Okay, so y prime, you have to use product rule here. Product rule. So y prime equals the derivative of x is 1, keeping natural log as it is, right? Plus x, what is the derivative of natural log of x? 1 over x. So x's cancel, so it's natural log of x plus 1. That's the derivative. Similarly, we could have this in the quotient rule also. So in the quotient rule, if given y equals natural log of x over x, don't cancel these x's. They are not, this x, you can't cancel these x's. This x is with natural log of x. It's a function of x, f of x, sine of x. You can't cancel. So natural log of x is a different function, and the natural log of x looks like this actually, right? The exponential looks like this, and y equals x is this. So don't cancel these. Don't cancel x's or anything. Don't do anything weird, okay? So using quotient rule, what was your quotient rule? X squared in the denominator, x as it is, the derivative of natural log of x is 1 over x, minus, instead of plus in this one, natural log of x as it is, and the derivative of x is 1, right? And these two x's cancel now. So you have 1 minus natural log of x divided by x squared. Okay, so Just keep practicing more questions on the exponentials, on the natural logs, and on the implicit. I believe this will be in test 2. The next set of functions are exponential functions, and not e to the x, but any kind of exponential function like 3 to the x, 4 to the x. I can send those in the separate recording because it's already 25 minutes. I don't want to send you longer recordings. It takes me forever to upload longer recordings. So I'll stop here and shoot me a question. I hope I've helped you with the implicit here. And also there's a question in for the discussions in this recording which you need to answer in the discussions. Okay, so that will be this week discussion, and let's see who can answer those questions. Good luck, good night, and keep me posted for your questions. Bye bye.